Metric prefixes. I will go over the symbols for prefixes, the equivalent meaning, some unit base, as you see below, symbols, and then trying to do conversions between different types of prefixes with the same base. So let us take a look at these prefix symbols. So I have pre-done this chart of various symbols of prefixes. Now, the symbol which you see here on the left-hand side, so these ones, and as they continue on downwards, the name of them, so as you can see, for example, capital G stands for giga, let's say H stands for hecto, and then on the right-hand side, you have the multiplication factor, so kind of the meaning of what it means. So if you take kilo, which a lot of people are familiar with, they know that kilo means 1,000. And that's what 10 to the power of 3 represents. So these are equivalent. Now I have done the base 10 to the exponent beside each of those prefix symbols. So trying to memorize this chart is not always easy. Trying to memorize anything isn't easy, but as you use the prefixes more and more, it does become a little bit easier. And the reality is that many of these prefixes we don't utilize. Now, some of them we may. For example, you may have heard of gigahertz or terabytes. So notice the word giga and tera are actually prefixes. And many of you maybe have heard of kilometers or kilojoules or kilograms. So the word kilo again is a prefix. Now, as you have these symbols, the ones that are above the orange line get bigger and bigger. And notice that deca, hecto, and kilo get bigger just by a power of 10. And then from kilo onwards, so going to mega and then to giga and tera, they jump by powers of 3. So multiplications of 1,000. Now below the orange line, the prefixes that we have, so deci, centi, milli, micro, and so on, these are for multiplications of 10, but now they're getting smaller. So notice deci is 10 to the power of -1. Centi, which you may have heard of before in, for example, centimeters, is 10 to the power of -2. So that, in terms of a decimal, would mean 0.01. Milli is 10 to the power of -3, which would be 0.001, and so on. So the most familiar ones that we utilize, I have outlined in green, and I'll kind of box them in right now. So these ones do come up quite a bit. Now, specific ones come up more often than others. Okay, so as we have. So for instance, the most common ones that you maybe have run into from these is probably kilo, centi, and milli, depending on what field or what you are familiar with in terms of some scientific measurements. Now, other ones don't come up as often, but are useful for us. In particular, if, for instance, maybe you're doing some health applications, or maybe if you're doing some engineering applications, for that matter. Now, these particular symbols that you see here on the left, and then the equivalent meaning of them in powers of 10 on the right-hand side are useful. And as you're just starting to work with prefixes, I would probably encourage you to try to have that little table with you at all times so that you can kind of remember what they mean. And as you use them more and more often, you will get used to them a little bit in a better way. Now, these are just the prefix symbols that we have, and then the actual multiplication factor meanings. Now, the next item on the agenda is kind of the base units, okay, that we have. Now, I will define a unit which is a base, maybe a little bit different than the standard definition. But for this purpose of the video, I will simply refer to a base as one of the metric units that does not have a prefix. So it is a metric unit, and it does not have a prefix, with no prefix. And I wrote some of these in the little bit of a agenda for this video. So here are some. There's obviously many more, depending on what field you're working with. Now, these ones, you may be familiar with some of them. For example, grams, which is G, meters, which is M, seconds, which is S, and now the other ones that follow, okay, which is joules, often used within energy, liters, often used for volume in terms of liquids, hertz, which is often used within frequency calculations. For example, beats per minute is a hertz, except it is per minute and not per second. Watts, which may be used in power. Pascals, which is often used in pressure. And then newtons, which is used in force calculations. So you may not be familiar with all of them, but notice that none of these units have any kind of a prefix, okay, symbol that is attached to them. And what I mean by that is, for example, if I take these three, which are the most familiar ones, and ones that you probably may remember some of the prefixes, for example, I can write mg, which stands for milligrams. So this right here that we have, grams, would be our base, and the actual milli would be our prefix. So what this actually means is that we have milli, which is 10 to the minus 3, if you go back to the chart. So, and then gram is just G. So instead of us writing 10 to the negative 3, what scientists have done is they have exchanged 10 to the negative 3 with just writing the symbol m in front of the unit G to represent that. So these two things actually mean exactly the same thing. So this milli, this m in front of the G, and the 10 to the minus 3 means exactly the same. So for instance, you could have written, let's say 3 milligrams, and that is equivalent to just simply writing 3 times 10 to the minus 3 grams, where we have our actual symbol, which is milli, and that is this 10 to the minus 3, which is being multiplied. So scientific notation, which is something that we have right here, that's scientific notation, has been at times replaced by these prefixes. And these prefixes just simply simplify things for us. Now, of course, it complicates things for the learner when they're just beginning, but once you get accustomed to these and you're working in a particular field, then using the prefixes is actually really useful. So that's what this actually means. Now, let's take a look at another meaning. So for instance, people may be familiar with kilograms. So if I say that my weight is 72 kilograms, and this is a small g. And now I go back to the table, then what I can do is that the kilo, the k that we have right here in front of the g, well, that just means 10 to the power of 3, and that is grams. So the base unit, which is g, which we utilize for mass, and then the little k that I have right here is basically equivalent to writing times 10 to the power of 3. So you can use either or notation, but over time we have adopted in the metric system the prefix notation much more often than we do the scientific notation, which you see on the right-hand side. So that's how this actually works. Now, when you are studying these things, it is useful to know conversions between different types of prefixes. So if I go back to the table here, I have kind of put a box, a pink box, over the prefixes which happen a little bit more often. And to help you, if you ever wanted to try to convert from one prefix to another, I will give you some examples and show you how you can use this table to do that. So first, what I'm going to do is I am going to, instead of writing the table up and down, I'm going to just simply take the base unit that I want. So now the base unit, as you have seen above, could be possibly grams. Maybe it is meters. Maybe it's seconds or joules. And of course, we can continue on with many other base units. And now on the left-hand side, okay, I will put the prefixes. So the prefixes, if you would be going in the direction of the table upwards, so as they get bigger, so the first one was deca, and deca just meant 10 to the power of 1. Then it was hecto, which was h, which was 10 to the power of 2. And then after hecto, it was kilo, which meant 10 to the power of 3. Now notice they are jumping by 1, and then the next one was mega, but mega was 10 to the power of 6. And of course, these can continue. Now on the right-hand side, the prefixes were getting smaller. So we had first deci, which was 10 to the power of minus 1, which is 0.1. Then we had centi, which was 10 to the minus 2, or 0.01. Then we have milli, and milli is 10 to the minus 3, which is 0.001. And then we have this funny symbol, which looks like a U. This is a Greek letter mu, and it is 10 to the power of minus 6. And notice the jumps that we have. The first 3 that we have, so 1, 2, and 3. And on the left-hand side, 1, 2, and 3, they only jump by 1 decimal spot, or 1 power of 10. But then afterwards, they start jumping by powers of 6. Sorry, by powers of 3. So from 3 to 6, and from negative 3 to negative 6. And that you can refer to the table if you wanted to go further down or further up on these prefixes. So why did I draw it in this way? Well, so let me give you an example here. And I'll give you an example where you have a base of just grams. So for instance, what if someone came along and told you, well, please convert the following, which I have, some measurement 145 milligrams, and I want you to convert this to, for instance, grams. So you will notice that, I have a prefix here, which is milli, and milli would appear right here. And now I want to get rid of the prefix, so I want to go back into the base, which is right here. So in order to do that, notice that you are going to be jumping, okay, from the milli all the way back into the base. So you're going to go from right here, which is milli, so you're going to jump once, you're going to jump twice, so that's 2 powers of 10, and then you're going to go back. Now the base is actually 10 to the power of 0, which actually means 1, and that's why it's the base unit. So you have jumped 3 places, and you've jumped in the direction to the left. So what happens is that you can simply do the conversion by taking the decimal spot, okay, and removing the milli by simply going in the same direction as you were moving 3 spots. 1, 2, and 3. So your answer in grams would be 0.145. And that is because you've jumped 3 decimal places to the left. So 145 milligrams is equal to 0.145 grams. So that's one example, okay, how to use the table. Let's take a look at another example. So what if now I would give you a different example, and this particular example, for instance, is 0.041, and now this is HM, and we want to convert to CM. So our base is changing. So our base, as you can see, now it's M, which stands for meters. So that's our base, new base M. And now we have to go from H, which is hecto right here, and we want to jump all the way down to centi, and centi is right here. So how do we do that? Well, we do exactly as we did in the previous example. So we start from H and we start our jumps. So we have 1, 2, 3, and 4. And we're going in this direction, and that's exactly where our decimal place will move. So we're going to move 1, 2, 3, and 4, which will be 410 centimeters. So that's how you can utilize this table between different prefixes as long as the base is the same. So that's a second example. Let's take a look at one more example, okay, on how to work with these. So let me clean up this and give you this particular example. For instance, 7.8, and now let's say it was DL, and I wanted to convert to ml. So this is actually deciliters, and we want to convert to milliliters. Notice the key is that your base, in this case liters, is the same. And the way that I would do that is I'm going to start from D, which is the deci, so that's right here. And I'm going to jump over to milli, so I'm going to jump 1, 2, and I'm moving in this direction. So that means I'm going to jump 2 decimal places over, which will give me 780 milliliters. Okay, so that's that example. Now be careful, because as you're doing your jumps, now in the first, from kilo all the way across to milli, the jumps are just one at a time. But if, for instance, you were jumping and someone came along and said, well, here is an example, and let's say it would be, for instance, 4.25 millimeters, and they asked you please convert to micrometers. So our base is meter, and we want to jump from milli to micro. So on our little chart, I'm going to erase here. On our little chart, what we have is, well, milli is right here and micro is right there. So it looks to us like it's one jump, which was the case for all the other examples. However, notice that in this case now, okay, that one jump, you're jumping 3 because the power has changed from -3 to -6. So in that case, you would actually have to move this decimal. Now you're still going to the right, but you would jump 3 times. So this would be 4,250 micrometers. So just be careful with that when you're jumping along those further out prefixes. All right, so that concludes how we convert between prefixes. There are a couple of instances which I want to point out to you, and that is when you are converting, for example, volumes or areas. So let's take a look briefly at a couple of examples where that may happen, and let's see how that chart will impact us. So here is an example, for instance, that is 1800 millimeters squared, and we want to jump to centimeters squared. So whenever you are dealing with a squared, and that corresponds to some measurement of area. Now our base is meters, but we have these prefixes that we want to change from milli to centi. What happens in this case? Well, in this case, what you have to be aware of is that the squared are jumps for each of the jumps. So for instance, we're going from milli to centi. So we are going in this direction, milli to centi. So it is just 1 power of 10 from -3 to -2. So you might be tempted to just simply move the decimal 1 spot. However, because it is squared, each jump is actually 2 spots. So my answer would be 18 centimeters squared. Again, okay, because you are squaring, then each of the jump is 2 jumps over. Okay, so be careful with that. Now, what if, for instance, I would give you volume, which is cubed. So in this example, if you would take 0.9, and let's say it was meters cubed, and you wanted to change this to hectometers cubed, so be careful here because, so now we have a base of meters cubed. So we're going from a base. There is no prefix on the first one, so our starting point is right there. And now the number of jumps is 1, 2. It's to the left that we're moving. So we're going to be moving the decimal to the left. But because it is cubed, each of these jumps through the powers of 10 actually corresponds to 3. So I have 2 jumps, but each of them is worth 3 decimal spots. So that means that I am actually, in this case, going to move 6 decimal spots, which is going to look very odd, but that's exactly what happens. 1, 2, 3, 4, 5, 6. So this is where your decimal spot will end up, and you have to fill in your zeros and that would be the answer. All right, so that concludes this video with regards to prefixes. Thank you for watching.